And welcome back, and it is the 8th of March, further maths, 5 a day, and let's go straight into the first question. Okay, so it looks like we have a pretty standard quadratic inequality. Now, if you do international GCSE, you don't actually do these at international GCSE, but I believe, haven't taught it for a few years, but I believe these are part of the normal GCSE syllabus. Your real question here is, what are we going to do? Are we going to do the inspection method to try and factorize, or are we going to do the algorithm method? And both work fine. And to be honest, just whichever works for you in an exam, do that method. So the algorithm method tells me that 3 times 6 is equal to 18. And then I'm thinking of two numbers that multiply to make 18 and add to make minus 11. Well, they're both going to have to be negative, aren't they? So it's going to be minus 9 and minus 2. Actually, I wasn't going to finish this, but let's finish it this way. So that's going to give me 3x squared minus 9x. So remembering the numbers, I want a minus 9 and minus 2. So 3x squared minus 9x minus 2x plus 6 is equal to 0. Factorize the bit on the left. So that's going to be 3x minus 3. Factorize the bit on the right. So this bit over here. So that's going to be minus 2. X, well, I've taken out a minus, so this has to be a minus as well. That's minus 3. X minus 3 is the same, which is good, because otherwise I have a problem, which is going to give me x minus 3, 3x minus 2. The other method is basically clever guessing. Now, obviously, I know what the answer is, so this makes it significantly easier. But I'll still suggest to you that the only real way of making 3x squared is to do 3x and x. Because that's a negative and that's a positive, I know both of these have to be negative. And then for the final part, I need two numbers that multiply to make minus 6. Well, we've already worked out they're both negative, but also add to give minus 11. So I'm probably, and again, I can see what the answer is already, but it makes sense. 3 times minus 3 gets me to minus 9, and then add on another minus 2 gives me to minus 11. So you can do the, again, sort of clever guessing method. That will work. But either way, my critical values, which will be a mark in the exam to show you've got these critical values, are going to be positive 2/3 and positive 3. Then quick sketch as to what I'm doing. So I'm doing a quadratic. It's a positive or a happy sloping quadratic. My key values are 2/3 and 3. So that's going to be 2/3 and that's going to be 3. I want all values that are less than 0. So in other words, I want them to be underneath the x-axis. And those values occur between the values of x is between 2/3 and 3. And obviously we can do it much quicker than that, but two different ways of getting to the same answer. Question done. Next question. The nth term of a sequence is, now again, if this is your first video you've seen, I'll walk through it quickly, but very similar to these questions, or more notably, all these questions are very similar idea. In long term, what I'm doing is I'm putting a very, very large number to here and a very, very large number to here. And that's essentially going to give me a very, very large number plus 9, which is pretty much just a very, very large number, and a very, very large number minus 4, which is still just a very, very large number. And then the n squareds will cancel, which is just going to give me 4/5. Now be careful, it's not, I mean, it kind of is just the case of looking at the numbers before, but understand why, just in case you get one of those clever questions either way around. The correct notation really is to say, as n approaches infinity, then this sequence approaches 4/5, because it never actually gets to 4/5. Either way, question done. Next question. The sketch shows a curve with equation, and then it's a negative exponential, as in it's going down, it's decaying, where a is greater than 0 and b is greater than 0. And it must be, because otherwise I'd have a curve that's going the other way. So in a way, the graph tells me that already. And then it gives me 2 points. So it gives me the point here and it gives me the point here, which feels very much like I can just put these points into the equation and solve a simultaneous equation. So using the first point, that tells me that 8 is equal to a times b, don't know a, don't know b, to the minus 2, which is plus 2. And the second equation is then very similar. So I'm going to say my y value, so 0.001. So again, I'm looking at my second point here, is equal to a that I don't know times b that I don't know to the power of 1, but it's not 1 because it's minus 1. Then I'm going to divide these functions out. Simultaneous equations, two unknowns, and instead of subtracting, I divide. So 8 divided by 0.001 is 8,000, okay? And a divided by a cancels out, always 1. B to the 2 divided by b to the minus 1 is b to the 3. Okay, now I see what's 8,000, and so therefore I get my calculator out, although I don't really need it, but I get my calculator out, do the cube root. Well, I know the cube root of 8 is 2, and I know the cube root of 1,000 is 10, so therefore this is going to be 20. So my b is 20. Then let's put this back in. So I'm going to use equation 2 for no obvious reason. So therefore a is equal to 0.001 divided by b that I know is 20 to the minus 1. Calculator out, 0.001 divided by 20, or it's actually just multiplied by 20, anyway, 20 to the minus 1 is going to be 1 over 50, or 0.02. And I actually didn't really need my calculator for that, did I? But anyway, never mind. What does it want me to do? Just wants the values of a and b. Let's just write those down clearly then. So a is 0.02 and b is 20, and that is question done. Is that it? No, actually one more question today. Final question. A circle has equation, write down the radius. Okay, pretty standard skill, and depending on what your textbook is and how it's taught, pretty much one of the first things I do once I've talked about what the circle is. Really common question. So I'm given an equation which appears to have too many x's and y's in, but if I complete the square, looking at the x's, that's going to be x minus 4 squared, take away the 16 that I don't need, plus y plus 1 squared, so plus y plus 1 squared, take away the 1 I don't need, and then I've still got a plus 16 over here. Now let's pull, and that's equal to 0. And let's pull all this together. So that's going to give me x minus 4 all squared plus y plus 1 all squared, and then minus 16. So again, tick as I go. So minus 16 plus 16 basically goes away. Minus 1 is minus 1. Move it to this side, it gives me 1. So that means my radius is not 1. Well, it is 1, but what I mean to say is it's a square root of 1, because it's a square root of this number here, which is 1. And so therefore my radius is 1. So hopefully that last sentence made sense. What I'm trying to say is just be careful not just to take that number. Either way, that is the question done. A really good mix of questions today. I really like those questions. So a bit of a mix of everything. Definitely a bit more further maths. Is that true? Probably half further maths, half just hard GCSE. But either way, let me know how you did, and do like and subscribe, and I'll see you for tomorrow. Thanks all.